So we all love seeing rainbows outside when they occur. So they're really beautiful. We see that beautiful spectrum of colors in that beautiful ball. But how do they work? So I'm going to explain that to you today. Now, to create a rainbow, you need to have three things: sunlight at a low angle, uh, clouds with a blanket of rain, and you. So let's formulate how those would work. Let's say we have the sun here, we have our clouds here, and our clouds are giving us a nice blanket of rain, and we have you in the middle. So now, how does a rainbow work? Now, what happens is the sun's rays come into Earth and reflect onto the raindrops. Now, the sun rays are formed of every single wavelength in the light spectrum. So for the colors we see, we have red, that would look kind of like this, and we have blue, that has a smaller wavelength, and it looks like this. And between these two wavelengths, as you make the wavelengths wider and wider, you have all the rest of the colors. And these colors order themselves in the rainbow we know, the Roy G. Biv. Now, how did they sort themselves in that way? So, as I said before, each sun ray is a mixture of every single wavelength of light, both that we can see and that we can't see. But right now, let's focus on what we can see. So, our rays are going to hit the raindrops. Now, let's see what's happening when they hit the raindrops. So we'll have an enlarged raindrop here, and let's remove ourselves real quick. And we have light that's hitting toward this raindrop. Now, as the light hits through this raindrop, different wavelengths of light are going to react differently to this raindrop. Now, red light, once it hits this raindrop, is going to hit the raindrop, slow down to a certain rate, and angle off at about 42 degrees. So, about 42 degrees. Okay. And for blue light, it'll do the same thing. All the blue light in this mixture is going to angle off at about, it's going to angle off at about 40 degrees. Okay. Now, and every color in between them is going to have its own assigned degree in which it angles off from. Now, how does this create a rainbow to us? Now, the way we see light is not that our eyes are quite sending something out and getting some signal back. It's that our eyes receive any photons going around. So when you turn on a light bulb, it sends around photons, and those photons bounce back from the objects into our eyes, and from which our brain colors whatever one we have. Now, what's happening here is the wavelengths are hitting this blanket of rain, and let's say about here, the red light, or about here, is where the red light is at a perfect angle. So you here, so the red light is produced here, it's sorted out here, and it releases at a 42 degree angle. And from this angle, at this specific point, you will only see red, because all the other colors, so if we have blue that's at 42 degrees, and this is 40 degrees, then this blue is not going to hit you. It's going to hit somewhere down your arm or something. And you're not going to see that in this spot. Now what happens is, so we have red here, and then a little bit higher, we'll have, my bad, it'll be a little bit lower, and at 40 degrees, this blue light is going to hit your eye just a little bit lower than where the red light was. And in between these, we're going to have the whole spectrum, the Roy G. Biv. So each color from this spectrum is going to have its own spot in that height, and their wavelengths will correspond to how high they are or how low they are. Now, you might be saying, oh, that's cool, but isn't that just one section of the rainbow? And yes, but this exact system is happening on every single point of the rainbow. So if we're looking at this point here, then we have the Roy G. Biv right here. And now the same thing is going to be happening here. So this angle is going to come at you perfectly for your eyes, for red, and then blue, or vice versa. And this is going to happen for every single point around that semicircle. And actually, it would happen for the whole full circle, except the Earth obviously blocks away the rain, and thus that phenomenon does not occur. And if you're skydiving or in certain places, then you might be able to see the full rainbow, since the water is able to conduct that and the light is in a perfect space. So, yeah, there you go, and that's how rainbows work.